If the number of the proton or number of hydrogen increase in the substance, we call that as alkali because it accepts proton. The definition of alkali, another definition, because there are many definitions for alkali. This is one of the definition in which accept proton. Whenever a substance accept proton, we call that as alkali. So first it is NH3, then it become NH4. If NH3 become NH4, it means the number of the hydrogen increases. If number of hydrogen increase, it means it accept proton. And whenever the substance accept proton, we call that substance as an alkali. So in this definition, according to the definition, in this reaction, NH3 is acting like an alkali. Same thing when you check water, H2O, after a reaction it become OH. So when you check what happened to H2O, it means it gives out, because first there are two hydrogen, then after the reaction only one hydrogen. So what it shows that it donated the proton or it donate the hydrogen. If the hydrogen number decrease, it means donating. If hydrogen number increase, it means it is accepting. So first it is H2O, two hydrogens are there, then it is only OH, so the number of the hydrogen decrease. If a number of hydrogen decrease, what we call this is donating proton. And if a substance is donating proton, according to a definition, that substance is acting like an acid. So acid, here in this example, water is acting like an acid and NH3 is acting like an alkali. With respect to the definition of acid and alkali, this is also known as Lowry-Bronsted concept of acid and alkali. You don't have to learn their names, you just have to understand the concept that acid is a substance which gives proton and alkali is a substance which accept proton. This is one of the definition to explain the idea, but this definition is not applicable in all the substances, because in all the substances it's not necessary there is a loss or gain of proton. That's why this definition of loss or gain of proton is valid only for few examples. Is it clear? Same way, another definition for base. Base is a substance which neutral. The definition of acid, acids are proton donors. You can see here, first it is H2O, then it become OH. So means it donate proton. Whenever a substance give proton, we call that substance as acid. And whenever substance it accept proton, like it was NH3, then it become NH4. So the number of the hydrogen increases. When the number of hydrogen increase, it means it is accepting proton. We call that substance as an alkali. But this definition of acid and alkali is not valid specifically for alkali. It's not valid for all the type of alkalis. This is only specified for certain chemical reactions. Same way, so another definition for base, it is a substance which can neutralize acid by forming water, metal oxides and hydroxides are generally bases. So this is another definition for base. First definition was in terms of proton, but the second definition is in terms of the metal oxide and metal hydroxide. They are generally known as a base because they neutralize the acid by forming a water. So example, acid plus metal oxide the result will be salt and water. Same thing, acid plus metal hydroxide, the result will be salt and water. So you can see here acid plus metal oxide and acid plus metal hydroxide, the result is salt and water. So acid is neutralized by a substance. That substance which neutralizes the acid, what we call that as base. And if the base can dissolve in water, yes, salt is also formed, but the main idea for a substance to be base, it should neutralize the acid and form water. So acid plus metal oxide and metal hydroxide generally refers to base. And if the base is soluble in water, we call that as alkali. And normally for alkalis, the substance which give hydroxide ion in the solution are known as alkalis. Is it clear? Metal hydroxide, I wrote base. Base is a substance which can neutralize acid and form a water. Normally metal oxide and metal hydroxide are the base. And if the base can dissolve in water, if you can dissolve the base in water, you call that as alkali. Like example, sodium oxide or sodium hydroxide. Both are water soluble. So if both can dissolve in water, metal oxide or metal hydroxide, if can dissolve in water, what we can call them as alkali. So we'll do one question related to salt and identification. A mixture of two calcium compounds are there. So you have two calcium compound or two compound which contain calcium, C and D. C is partially soluble. Compound C is partially soluble, a small amount is soluble, and D is completely soluble. The mixture of C and D were added to a distilled water in a boiling tube, and the tube was shaken and the mixture was filtered. The filtrate, it was divided into 5 equal portions. What will be filtrate? Likely to be filtrate. No, the question, you have two compounds of calcium, means you have a compound of calcium. C and D are the compounds of calcium. Both contain calcium, but what else with calcium you don't know. My question is, you make a solution and you filter. Which of the compound is filtrate? Compound D or compound C? C is partially soluble, a small amount is soluble. D is completely soluble. So which will be filtrate? Filtrate means the substance which can pass through a filter paper. So actually D is the filtrate. Because, so is it clear? Like you have C and D, you add a distilled water, you shake the mixture and you take a filtrate and divide the filtrate into 5 equal test tubes. You divide the filtrate into 5 equal test tubes, and filtrate is D, compound D will be filtrate. It will have some small amount of C, but more likely it will be D. Now the question is, to the first portion you add sodium hydroxide little at a time. If I add a small amount of sodium hydroxide, and I know this is compound D, and compound D contain calcium, and I don't know what else with calcium, but it's calcium. So if I add small amount of 5 drops of sodium hydroxide, what is the observation? Yeah, right, it will give white precipitate or white PPT. Yeah, that's correct. White precipitate. Even in exam, you can write PPT. That's accepted.
How will you know it?
What?
How will you know?
How you will know? If you last week I just shared one test for the positive ion, that table which you have to memorize. And if a compound contain calcium and you add sodium hydroxide, so that compound will give white precipitate.
All right.
So it's actually related to memorization of the test for the ions. If you add an excess of sodium hydroxide, what is the observation? If I add an excess, so precipitate does not dissolve. You cannot say no observation, you can say no visible change, because the precipitate are still there. So you can mention no visible change. Precipitate does not dissolve. To the second portion, we add aqueous ammonia. If a compound contains calcium and we add aqueous ammonia, what we observe? Yeah, good. No reaction is a right answer. Again, this is related to memorization. If you add aqueous ammonia in the calcium compound, there is no reaction or no visible change. Is it clear to everyone? Next is, you add sodium hydroxide, and to the third portion was added sodium hydroxide and aluminum powder. Can you identify what is this test for? This is a test for which ion? When you add sodium hydroxide and aluminum powder. Yeah, good. It's no, it's not for halide. It's for nitrate. This is a test for nitrate ion. And whenever you test for nitrate ion, you add aluminum. You will add sodium hydroxide followed by aluminum powder, and a pungent gas is given off which will turn red litmus paper blue. So what it confirmed? It confirmed that there was nitrate as well. So what is this compound? What is compound D? You can identify calcium was there, and this test indicated it is nitrate. So what is this compound? No, my question, yeah, compound D is calcium nitrate. The gas is ammonia. So compound D we identify because of nitrate ion, so it shows that it is a calcium nitrate. Yeah, CaNO3 in a bracket too. Good. The pH of the fourth portion was tested, and it pH was 10. What it indicate? If the pH of the solution is 10, what it contain? It's an alkali. It's, so pH 10 indicates that it is an alkali. And carbon dioxide, it's a weak alkali. Carbon dioxide was bubbled through fifth portion. It turned milky. So it shows it is a lime water or calcium hydroxide. Look, I will repeat what happened in the question. I'll repeat again for everyone. Look, you have a mixture of C and D. C is partially soluble, a small amount of C can dissolve, and D is completely soluble or de-dissolve. So C and D were added to a distilled water and the test tube was shaken and the mixture is filtered. The filtrate was divided into 5 equal portions. So there are 5 portions of filtrate. This filtrate, because D is completely soluble, so it contains mostly D and maybe small amount of C will be there. Why I'm saying small amount of C? Because C is partially soluble, not completely insoluble. So maybe some C is there, but mostly it will have D. And we already know these are calcium compounds. So if a compound contains calcium, and you add sodium hydroxide, so you will observe white precipitate. You have to memorize this table, the test for the ions, so that you can answer this. If you add too much sodium hydroxide, what is the observation? Precipitate will be insoluble, does not dissolve. If you add to the second portion, you add aqueous ammonia. If you add aqueous ammonia and a compound contain calcium, then there is no visible change, no observation. Then to the third portion, you add sodium hydroxide and aluminum. If you add sodium hydroxide and aluminum, this is a test for the nitrate ion. So this indicates that this contains nitrate ion. The pH of the fourth portion was tested. If pH is 10, if pH of the solution is 10, it means it contains hydroxide ion. Or it's a weak alkali. And when you pass carbon dioxide, it will turn milky. So means that solution is a lime water. And lime water means calcium hydroxide. So now the question is, name a gas given off in test A3. Which gas is given off in A3 when you add sodium hydroxide? When you add sodium hydroxide and aluminum powder, which gas is given off? Suggest an explanation for observation in A5. A5, what it shows it is a lime water. What is this observation shows? A5, whenever you pass carbon dioxide through a solution, it turned milky, so it shows that it is a lime water which turned milky because of carbon dioxide. That's good. Look, the original solution was calcium nitrate. Solution contained calcium nitrate and calcium hydroxide. And you have to, for the positive ions, you have to add sodium hydroxide. And for negative ion, there is a specific test for them. So actually, it's not like you can add anything. It is always according to the test which you learn for positive ion. It's not like you can add anything. Is it clear, this question? Question 5, page 3. Because question, okay, so tomorrow also we'll do one more question. I will revise acid and I will do more questions related to. Yes, the compound C is actually a lime water. That's right, Afif. And compound D was calcium nitrate, and all nitrates are soluble. That's why. But they did not ask identify compound C and D, so you don't have to answer for that part. Any question related to